I'm Lavanya, Assistant Professor, Department of Chemistry, St.Josephs College of Arts and Science for Women, Hosur. Now we are going to discuss about the organic chemistry. So here, what is mean by stereoisomerism? In the stereoisomerism, another name is called as a configurational isomerism. When isomerism is caused by the different arrangement of atoms or group in space, the phenomenon is called stereoisomerism. In Greek words, stereos means occupying space. The stereoisomers have the same structural formula but different in the spatial arrangement of atoms or group in the molecule. In other words, stereoisomerism is exhibited by such compounds which have identical molecular structure but different configuration. It is also called as configurational isomerism. So here two structure will be the A and B. Both also we can able to consider as a chiral compound because of center is carbon, around the carbon atom having a 4 different kind of atom. That's why this is called as a chiral compound. So here normal line represent the plane of paper, the wedge line represent the bond in above the plane of paper, dotted line represent the behind the plane of paper. So the above given compound is considered as a tetrahedral structure. Because of here and all will be attached as a 4 different kind of atom around the carbon atom, like that means central carbon atom. In this stereoisomerism is 2 types. One is optical isomerism, one more is geometrical or trans isomerism. First one, optical isomerism. The compound that rotates the plane polarized light is known as optically active compound. The rotation of plane polarized light is referred to as optical rotation. Compound having similar physical and chemical properties but different in the behavior towards plane polarized light is known as optical isomers, and the phenomenon is known as optical isomerism. So here geometrical isomerism, another name is called as trans isomerism. The compound having a similar molecular formula but different arrangement of atoms of group in space around the double bond are called geometrical isomerism. So here always geometrical isomerism we can able to find out only in the carbon-carbon double bond compound. The geometrical isomerism arises due to the restricted rotation about the carbon-carbon double bond. Here given as a 2 example, fumaric acid and malic acid. In fumaric acid to functional group COOH group in opposite side, but malic acid to same side. Opposite side to is the that is trans compound. Same side means cis compound. So fumaric acid is trans, malic acid is cis compound. So from these two, one to fumaric is more stable than the malic acid because trans compound is more stable than the cis. Next one, optical activity. Light is propagated by the vibratory motion of the ether particle present in the atmosphere. Thus in ordinary light vibration occur in planes at right angles to the line of propagation. In plane polarized light, the vibration take place only in one plane, vibration in other plane being cut off. Plane polarized light that can be obtained by passing ordinary light through a nickel prism. See here, first one is the ordinary light will be passed all the direction, that means vibrating in all the direction. This will be passed throughout the nickel prism. No, it changes a plane polarized light. This plane polarized light only vibrating only one direction. So the compounds which rotate plane of polarized light are optically active compound. It's known as optical activity. If the compound rotates the plane of polarization to the right, that means clockwise, is called as a textorotatory. In Latin words to textor means right. It is denoted by the symbol plus, otherwise small letter d. If the rotation to the left, that means anti-clockwise, the compound is said to be levorotatory. In Latin words, levers means left and is denoted by symbol is minus or small letter L. Now the notation D and L is not used. Specific rotation is mentioned by the letter is alpha. The change in the angle of plane of polarization is known as optical rotation. The optical rotation is detected and measured by an instrument called polarimeter. The degree of rotation depends on the nature of the compound, the temperature, solvent, concentration of the solution, length of the polarimeter tube, and wavelength of the light used. So here alpha means specific rotation, T means temperature of the compound, lambda means wavelength of the light used. Here alpha means observed angle of rotation, L means length of sample tube.